Hi, this is King of Review. Here we have two graphs, y equals 2 to the x and y equals x. Now there are several letters labeled on the x-axis, and we need to use those in the problem we're trying to simplify and in one of our solutions. So let's see if we can relate some of the letters to each other. We know that A corresponds to a point on the graph y equals 2 to the x, which means this point here is y equals 2 to the a power. But this also corresponds to this point on the line y equals x, and since y equals x, b is also equal to this same value, which means b is equal to 2 to the a power. In a similar fashion, we know that this point up here has a y value of 2 to the b, but that is equivalent to the y value on this line, which, since y equals x, is equivalent to the value of c. c equals 2 to the power b. By the same logic, c takes us up to 2 to the c, which it corresponds to d. d equals 2 to the c. And d takes us to the point with a y value 2 to the d. If we bring that over to the line, this y value is also 2 to the d, but that's the same thing as e. So we have all these relationships. Now, since what we're trying to figure out has a bunch of log base 2's in it, let's try taking the log base 2 of each side of all these problems. And let's use the first one as a nice example, since they'll all work the same way. I can take the log base 2 of the left side and the log base 2 of the right side. Now on the right side, we have the log base 2 and 2 to the power a. There's a property of logs that says if you have a log base b of some number a and that equals some other number c, this is the same thing as writing b to the c power equals a. So now let's bring this back to what we're working on. We have the log base 2 of 2 to the a, and let's set this equal to, let's call it x. If I use this property up above, we can rewrite this as 2 to the x equals 2 to the a. Since 2 and 2 match, x must equal a, which means the log base 2 of 2 to the a is just equal to a, which means, bringing that back over to the left, the log base 2 of b is simply equal to a. Using the same logic in the second equation, we'll call this equation 1, in the second equation, c equals 2 to the b, will result in the log base 2 of c is equal to b. In the third equation, we'll have the log base 2 of d is equal to c, and in the fourth equation, we'll have the log base 2 of e is equal to d. So now let's come back to the original problem we're trying to simplify. We have the log base 2 of the log base 2 of c plus the log base 2 of the log base 2 of e. But now we know that in our first log, the log base 2 of c is simply equal to b. So this is just the log base 2 of b. In the second log, we have the log base 2 of e, but according to equation 4, that's just d. Now we're already down to just 2 logs, but we can go further. We know the log base 2 of b from equation 1 is equal to a, and we know the log base 2 of d from equation 3 is equal to c. So our entire expression simplifies down to just a plus c. And that's it. Thanks for watching.